Good afternoon to all of you. Today I am going to present my topic, comparative study of DNA topoisomerase in viruses, prokaryote and eukaryote. Briefly, topoisomerase is the biological molecules that is essential for maintaining DNA topology and its conformation. The sources from which I have obtained DNA topoisomerase are Salmonella phase, Vaccinia virus, E. coli and humans. Or I have downloaded the FASTA sequence and PDB file of DNA topoisomerase from the UniProt. The data showing in the slide are obtained from the pot param. The second column correspond to pi, third column correspond to number of negative residue, and fourth column correspond to number of positive residue, and fifth helix percent, and sixth or sixth percentage. Comparison between viruses. In this slide, I have done multiple sequence alignment of two different topoisomerase obtained from two different viruses. Second, I have done secondary prediction, structure prediction by using CFSSP, or the figure showing I have obtained it from PyMoles. From multiple sequence alignment, our sequence score is 99.4%. But when you look to the tertiary structure of both topoisomerase, topo DNA isomerase 1 from Salmonella phase and DNA topoisomerase 1 from Vaccinia virus, we see that beta sheaths are quite distant, but in case it is quite closer. Besides, they have score of 99%. The reason may be the due to of because there is difference in the negative and positive charge residue in both topoisomerase 1 and in Salmonella phases and Vaccinia viruses. Or our third image is the superimposed image of both the tertiary structure. We find that only 60% are superimposed. Beside it has 99.4% identities. We have only difference. It is only difference in the two regions. First this and second this one. Or this slide show the comparison between E. coli topoisomerase between the E. coli one. I have taken DNA topoisomerase 3 and DNA topoisomerase 1 from E. coli. This is the multiple sequence alignment. This alignment is not so good. Alignment score is 20%. Or this is the secondary structure prediction. But interesting point to notice that they have the sequences are very low, but secondary structure, tertiary structure alignment are perfect. I don't know why it is, but it is very matching with the superimposition. Or this slide show the comparison between human topoisomerase. I have done multiple sequence alignment of 4 different isotopomerase, but only in the second and third row the identity is 68. Other combination has identities less than 10. Or this is the tertiary structure obtained from pi mole of DNA topoisomerase 2 beta and DNA topoisomerase 2 alpha in human, or this is the superimposition, but as compared to a score, it is the superimposition is acceptable. Or I have done multiple sequence alignment between viruses, human and E. coli. The score is of all this is below 5, so most of the region are not matching. There are lots of gap and all this thing. And finally, I have constructed the cladogram by using cluster W. We clearly show that E. coli topoisomerase has evolved earlier than human DNA topoisomerase. Or finally, conclusion that in viruses the sequence are very much conserved. In E. coli the sequence are slightly better, but in humans the multiple sequence arrangement are very poor.